Today we are going to see that elevator control exercise. Okay. Here we consider we are having now that one simulation of that elevator where you see this is the ground floor. So ground floor in that one, this is ground floor. This is a ground floor, right? So here we are having now this is a ground floor, and this is first floor. This is second floor. This is third floor. Right here we are simulating that lift as like that LED glowing, right? So here suppose you assume that one the lift is in the ground floor, right? Now here we are having now the corresponding floor switches, right? So this is a switch for ground floor, this is a switch for first floor, switch for second floor, this is third floor switch, right? If you are closing the switch, right? So here you see this one, this is a switch, right? If you are closing the switch, then this is connected with ground. Then here what it will happen here, this is the connection. So this is connected, right? So that one, if you are closing the switch, now this is connected with ground, so that this is a power supply VCC. So ground is connected. Now if you are pressing the switch, immediately the corresponding floor LED will glow. So this LED will glow because here power supply is coming now through the direction and is going to have in the ground, right? So that one, so that LED will glow. Okay. Then suppose you are pressing the some other key, then it will glow the corresponding LED, right? Okay. This is the case, right? Then what it will happen here, so that system will identify that one. So this first floor we are having now the sorry, second floor button. Okay, the first floor, so sorry, here actually this is connected with this one, first floor, this is connected with this one, so this is connected with the second floor, right? So the second floor LED will glow, right? So here now this is our request, second floor request, right? Then here what it will happen here, then this LED will glow, that continuously is glowing up to that here, then it is reaching to that particular LED. Now this LED will glow. So what you mean by that one, as the lift is coming up until the second floor, now this LED will off, switch off, right? So this is the case we have to do that one, right? Then after that, suppose next request is coming now that in the ground floor, right? Then that this lift is going to come down to reach that one, right? So if you are pressing the switch, this LED will glow, and then here this is going to start now come down until to reach the ground, right? Then after reaching the ground, that LED is glowing, now this LED is off, so it's reaching now. So in that manner we have to write an assembly program using the uh, programmable peripheral device 8255. So 8255 is a programmable peripheral device, right? So we are having programmable peripheral interface. So this programmable peripheral interface, right, is an IC, is available in the 8085 kit, right? So we are having now that 8255 is a programmable peripheral interface PPI, is an IC, right? So in that IC, what we are having now port A is one port, 8-bit port, port A, port B, port C, port B, and port C is there, right? Three ports are there, each one is 8 bits, so 24 pin, 24 ports, 24 pins, right, on the port, and two more pins are used for ground and power supply. Ground and power supply we are having now the two pins, so the 26 pin IC. Okay, now in that one we are having now the port A, port B, port C. The port is going to be used to connect with the external device, so you can connect the external device, external device, right? So from that device we can send the data and receive the data, right? So from the external device to input the data using the instruction in, right? You can send out the data using out instruction, right? Now here this port A, port B, port C, we can configure either this as input or output. And also this port A and the C upper is going to have that one as one group as group A. Group A is combined together port A and the C upper. So upper nipple, that is having now the C 7, 6, 5, 4 pins. Now this one as group B is another port, right? So this is port B and C lower, the lower one, right? So that one has 0, 3, 2, 1, 0 pins. So this is the lower, right? Now here this group A, group B can be configured through in what mode we want to execute, then we can configure that one, right? So for that we are having now another component is there here within that IC is control word register, control register. So this is we are having a control register in that IC at 8255, right? In the control register, what control word it is, according to that one, this is configured as either input or output. And also we can have now the mode of operation, a simple IO mode, or we are having now the handshake mode or bidirectional mode. What do you mean by that one? A simple IO. So we are sending that data as a input output. That is simple IO. Another one is we are having now handshake mode, right? So here we are having now, if your unsynchronized device is connected now, we are sending the data, it will send back the acknowledgement, then it will give that ready and it will give that request, like it will give the handshake signals. Through the handshake signal, it will transfer the data, is called that mode 1. Another one, mode 2 is bidirectional. So it can send the data and receive that. So you can configure as bidirectional, right? Now we should know about the how we have to configure through control word. So here we are having the control word is actually 8-bit data. Control word is 8-bit data. So the control word is having T7, T6, T5, T4, T3, T2, T1 and T0, right? So that one is here. We are having this is the configuration of the port A, port B. Port B, right? If you are setting this as 0, the port B is output, right? So out is for output. If you are setting that value 1, then it will configure as input. Then here we are having now, this is for C lower. So C lower also 0 is output, 1 is input, right? Now in what mode we are going to, either in IO mode or we are having handshake mode, is depends on this one, right? So 0 is IO mode, then 1 is handshake mode of the group B. Next one, here we are having now, this is port A, then this is C upper. The T3 is C upper. T3 is C upper, and then here we are having this T6 and T2 is used for the mode of group A. So this is group A, right? So this is so port A and C upper is group A. This is group A, right? Then this one is group B. Port B and C lower is group B. Right. Then here this is for the mode of group A. So 00 is IO mode, 01 is handshake mode, then 1X. X is we can have a tone gap, that 0 or 1, the 10 or 11 is configured as this one as bidirectional. Then the T7 is used for here the overall our IC is in IO mode or pit set reset mode, PSR. Now we are going to use that IO mode only. So we are setting now that IO mode for 1, then 0 is bit set and reset. So each bit can be set and reset. That is another mode, right? Now we are going to see only the mode of IO, right? So here now how we are going to configure now the port B. In that port B we are connecting with switch. Port B is connected with switch. So this is act as input. So we are giving that that particular switch is ground floor switch is connected with the BB0, then the BB1 is first floor, then BB2 is second floor, then BB3 is third floor. So port B is input. Port B is input. So the switch is input. So port B is input. Then here the LED is output. So that is connected with port A. Port C is not using here. Port A, right? Then how do you configure? This is output port. Out, right? This is in. Port B is in. So now here we have to configure all are IO mode, right? So that is first one we are having the overall is IO mode. Then the symbol IO 00, then port A as output port, then port C whatever it is, just I am putting now output because port C is not using here. Next one here we are having that this is we are having that third bit. So this is we are having that symbol IO mode, and then port B act as a input mode, and we are having the C upper, don't worry about that one, right? Then what value we have to set? This is 2, this is 8. So we have to pass that value to control word. So in the control word, if you are putting that 82, this as input, port B as input, then port A as output. So this is the in that circuit diagram process. Then we are going to see the program. Now we concentrate on the program. Right. Now you see that one. So first one, you have to move immediate 82, and then this control word addresses 43. Control word address is 40. So in that 43 we are putting now 82. So in that 43 we are putting now 82. 82, right? So 82. 002, right? So this is 8, this is 2. So we are configuring port B as output, port P as input, and port A as output. This is port A. Port A as output, right? Now here what we are going to see now. So first we are configuring the control word. So the control word of 8255 is 8 and 2, right? Check. Next we have to initialize that B as 0. So we are having the initializing B as 0, then B is moved to A, and then we are having R immediate with F0. So what we are going to have now, then all are 0, then F0, then we are having R operation with F0. So we are getting now that one as here we are having now port. So all are 1, then this is 000, right? Then we are having, this is actually we are having now that PA7, PA6, PA5 and PA4. Now all LED will glow for that. So we are sending now that out to port A. So port A address is 40. Port A address is 40. So in that port A we are sending now, then all higher bits are 1, the lowers are 0. Right? So this we are doing that OR operation with that 0, then we are getting now this F0. So this all LED will glow. While on switch on that one, then all LED. So here we are having now that four LEDs connect with that one, then all LEDs are glowing now, right? Now here you see this one here in the currently you assume that one we are having in the ground floor, right? So the floor is the ground floor. So initially we are having that address 8C53. In that 8C53 what we are having now, 8C53 we are having 00. So that is ground floor, right? Then 03 is first floor, 06 is second floor, 09 is third floor, right? Now here we are having, this is in that order we are having now 53, 54 we are having this one, 55 we are having 06, 56, 09, right? Now here that this the data is currently is there, right? Now you see that. Now in here floor is this 8053. So this address, so we are having this is 0. So that 0 is pass on to port P. Sorry, it's not pass on port B, right? So this is the HL pair is we are initializing with that HC53, right? So HL pair is initialized with HC53. Now we are getting that input from port B. So port B is a input device, input port. So here from that one we are getting now the data. So port B addresses 41. So through the address, we are getting now the input in IN41. So whether any switches are on or not, right? So here now this is one second floor switch, first floor switch, then like we are having, right? So ground floor, first floor, second floor, third floor switches are there, right? So this is connected with, we are having now that this is BB0, BB1, BB2, BB3, right? The higher bit is not using, right? Now here if you are pressing any one of the key, the pressing the key is giving 0. If not pressing that value, all are 1, right? So currently all are 1. If you are pressing a key, this particular key is going to have a 0. So now initially if you are not pressing any key, so in the all are 1, right? Now we are doing that here we are R operation with that F111. So what we are having now, in that port A we are having this is the current status. So all are not pressing the key. Then this is R operation with that 110, R operation with that 110 000. So we are getting now all are 11, all are 11, right? Now what we are going to have that one, we are moving C to A to C, then we are having subtract immediate with F of A to C. So we are saving this value, right? The C value is this one, right? So A is here, this value is saved, A value is saved in C register. So that is here, move C to A. Then what we are doing now, subtract immediate with F of, right? So that accumulator is having this one. So accumulator is having this value. All are 1. So it's not pressing any switch. All are 1. This is the accumulator, current content of accumulator. Now we are doing that subtract immediate with F of. So subtract immediate with F of means 2's complement of F. The 2's complement of F of is here all are 0. Then we are adding the last bit as 1. Because 2's complement, right? So F of is all ones. The F of 1 in complement of that F of is 0 0 0 0. Then 2's complement is we are adding 1. So we are getting now this one as 1 0 0 3 0 and that one, right? Now we are adding, so we are having adding accumulator with the 2's complement of that one. So we are getting now all are zeros, summing this one, right? 1 plus 1 0, then here we are carry 1 plus 1 0, 1 plus 1 0, like it will get that all are 0. At final we are having one carry is there, right? So the result is the 0 flag is setting now. So if you are not pressing any key, the 0 flag is setting now. So the 0 flag is setting now, jump on 0, then it will continuously waiting for pressing any switch on port B, right? Now until that not pressing any key, there is no disturbance in the circuit. Now if suppose you assume that one, the second floor key is pressing now, so that value is 0, right? Then what it will happen here, then in the input port we are getting now that value, right? So this one is 0, this one is 0. So here what we are having now, this is here 4 zeros, and here we are having 1. This bit is 0 because we are pressing second floor key, right? Now we are doing that here we are having now R operation with this one, right? F0. So we are getting now that one as R 4 1, and then here 1 0 1 1, right? Now this is this, right? Now you see this one, this 0 flag. So if you are doing that one, so is not 0, right? So here we are having now this subtract immediate with that F of, what you will get now, some value you will get now, right? So here this if you are subtracting that value with this one, so this one is complement, then we are getting now this is 0, right? 0 0 1, right? So we are getting now some value, it's not 0. Then this condition is not satisfied, then it will come down the next one, right? So 0 is not there, you are pressing some key, so 0 is not there because of that 0, right? Now this value is saved on C register, right? So is this one, this value is saved on C register. because always we are having now that accumulator is going to C. Next continues that one as here. Right. Now here what we are having now, that C to A, right? So in C what we are having now, 0 0 0, and here we are having now 1 0 1 1 because of the second floor, right? So ground floor, first floor, second floor, and third floor, right? So that is the case now here, right? Now what we have to do is rotate accumulator, right? So this is come to accumulator. So in that accumulator currently now we are having this the value. In that accumulator currently we are having now this the value. So accumulator is currently now we are having this the value, right? Now we are having rotate accumulator right. So rotate accumulator right is in this direction, right? So here we are right shifting that one. Now what we are having now, the carry flag will set. So because of this one is come under carry flag, right? Then first time we are getting now that one shift is here, so that rotate accumulator right. Now we are getting now that C to A, C current, then jump no zero, no, sorry, some no carry decide, right? So here carry is there, then what you have to do is INX sketch. So this is increment sketch pair. So I told you that one in that HL we are having 8C53, we are having 0 0, then 8C54 we are having now that 0 3, then 8C 5 5 we are having now the 0 6, right? Then 8C 5 6 we are having now 0 9. So that is in this particular key is pressing now, right? So that value is 0 6. So this 0 6 here we are having now that INX pitch, right? So that one is here. So we are having the first carry, the second also carry occur, and third there is no carry. So that is in the second floor clicking. So that's at the same time the HL pair is moving to here. So we are getting now that input through by pressing that key, we are getting the effect of this 0 6. Now the 0 6 we are getting now, right? So in that HL pair we are having now the HL pair is showing this location, right? Then what actually we have to do is, then here what every time then we no some jump on carry, you have to go to the loop, right? Where the carry is not occur, then we are getting now the corresponding address. This the case is doing now that in the loop 3. In the loop 3 is finding out where the switch is pressed, where is the corresponding the floor. So that is the floor is second floor, or the corresponding floor is second floor. So this is ground floor, then this is first floor, this is second floor, this is third floor, right? So the what key is pressing, the corresponding second floor HL pair address is moving now through the INX gauge, right? Now we are reaching that one. So this this no carry is occur now in that second floor. So no carry is occur, then you have to come to the decide part. So no carry, you have to come to decide. So you have to decide that one whether you want to move up or down. So that's the case, right? So that is, if you suppose LED is in the ground floor, then you have to move up. Suppose LED is in third floor, you have, because this is the second floor, so you have to move down. So that one we have to decide. So how do you decide? Either you want to up or down, right? So now you see this one. Here we are having now that call delay. So every time you have to call some delay, because that the LED is glowing now, then you have to show that lift is going by with some delay. So what we have to give, we call one delay, as simulate that one as like that in digital clock, the same like. Then we are having a less value of the delay. So the delay is 0.4 milliseconds or something, right? Leave it that one. Now here the HL pair is this one. So we are getting now this value. So accumulator is having 0 6. Accumulator is having now 0 6. This value is taken now because of the move M comma A. That M is this location. HL pair is this location, this address. So the HL pair is M. That M2 accumulator. So accumulator is now getting 0 6, right? Now you have to subtract B. What is B now currently? B is there that where the lift is. So lift is in ground floor means it is 0 0. Now you have to subtract B. So A minus 0. So this is 0 6, A is 0 6, B is 0 0. So that is we are having 0 6, right? So we are having the minus going down, right? So this is we are having plus. So what it will come to now? You have to move your lift upwards. Move your lift upwards, right? So the minus is not there. Then you have to jump on zero is reset. Not here not zero. So we are subtracting. We are getting some value, right? Zero means it going to is a reset position, right? So that the same zero position you have to move. So for that we are coming jump on zero, you have to reset, right? Now we here what we have to do is, right? So that reset means then it will reach the zero. So we are having now some down, right? So now what we have to do is increment b. So that one is 0 0 to 0 1. So next led we have to close, right? So move b comma a. So that one we have to move. Then here, right? Now we have what we have to do is here is a accumulators we are having now the 0 1. So right, so 0 1 currently. Then we have to go for output party is out in the port A, right? So in that port A we are having now that LED 0 to 1 is coming now. So 0 0 to the 0 1 LED will glow, right? Then you have to go for decide, right? So the decide is continuously is doing now. Then 0 6 minus 0 1 is a positive. Then it will come to once again then up. Then it will go to 0 2. Then it will come. Then 0 3 it will come. 0 4 it will come. Then 0 5 it will come up, right? Then 0 6 is reaching. Now we are getting now the 0. So it is a, in that case we have to go to the reset position. The reset position means the lift is reaching the second floor, and also that LED is glowing here because of the switch. Then we have to go for the reset position. The reset position means once again then we have to wait for getting a key, right? So that one is we have to make, right? So what we are going to have now, then move immediate A05, right? So we are having now the 05 is added with L, right? So what is it is the 05 is added with HL pair. Added with HL pair is in that HL pair we are having the corresponding value, right? So what value we are having now? Here what value we are having now, this one as, so this is a position now. From that position we add 5, 1 2 3 4 5. So we are getting now P6. So that one as 0 3 0 0 0 3 0 6 0 9. So that is we are having ground floor. This is a first floor, this is second floor, this is a third floor, right? The corresponding value here is E0, D3 and B6 and 7 9. Right? So this is the reset case. So that one is here we are having now the currently 06. From that one we are adding 5. 1 2 3 4, right? So here we are having now that adding 5 is here. Now we are reaching now then corresponding P3. P3 is used for resetting. So that one is right. So here what we are having now, this is the value we are getting now. Accumulator, in that accumulator we are getting now B6, right? So B6 is here, B is 1 0 1 1, then we are having now 6 1 0 1 1, right? So this is 6, then this is 1, right? So that one is here once. So what we need to have that one, the reset the corresponding second floor light, right? So second floor light is now reaching that LED, then the second floor light is we have to reset. So for that we have to send this data to the port A. So uh, this will switch off the light. The second floor light is going to be switch off, right? Then that is going to have now. Then you have to come to that original mode or the reset mode. So that one is here after resetting. Then it will come to that loop one. Then it is waiting for getting any pressing on the key. So corresponding that key you have to come up and come down, we have to move. So this is the program we are having now. You once again you go through, then if you are having a doubt you can make a query. Thank you.